This video is on the unit called redox. It's an introduction to the idea of what it actually means. Now, if you understand this first video, everything kind of falls into place. So redox stands for two words, reduction and oxidation. And they have to do what happens with electrons in a lot of chemical reactions, but not all of them. So let's imagine we have a reaction that we did in class, okay? Now, let's imagine we have some magnesium ribbon, just like in a lab we did. And there's oxygen in the room, and they react. And we did this. We set some magnesium ribbon on fire. All right. Now the magnesium starts as an element. Like all elements, it's a neutral atom, which means it's 12 protons, which I looked up on the periodic table, and it's got 12 electrons. Right. This is its electron configuration down here, and it has two valence electrons. And it reacts with oxygen. Now I have to write this O2 because that is the formula for oxygen. And I'm going to balance this as well later. Actually, I'll do it right now. I'll put the 2 here and 2 here. But I'm really not interested in that right now. What I'm interested in is what's happening with the electrons during this process. Because what ends up happening is this. The magnesium starts off as a neutral atom with a charge of 0. Each of the oxygens starts as neutral atoms with charge 0, right? Each oxygen there has 8 protons and 8 electrons. And then they form a compound. Now, this compound has a metal and a non-metal. This is magnesium oxide. And like all ionic compounds, involves a transfer of electrons. And in that transfer of electrons, what happens is the metal becomes a cation. So the magnesium is going to lose its 2 electrons here, essentially, right? And so the magnesium loses 2 electrons, and it becomes positive 2. Now, what's important is how its charge changes, which we're going to turn and call oxidation numbers soon, but not yet. The oxygen turns into oxide. It gets these 2 electrons, so these are going to be gone, and this ends up being positive, this ends up being -2. Now, why is the oxygen negative? Well, because it's gained electrons, right? Because when you gain an electron, right, electrons are negative, you become more negative. If I give you something negative, you become negative. The thing that gives away the thing that was negative becomes more positive. So think about what's happening here, right? The magnesium is going from 0 to +2. The oxygen is going from 0 to -2. Now I'm going to give the definitions. Oxidation is loss of electrons. Reduction is the gain of electrons. And see if you can answer who gained the electrons. Was it the oxygen or the magnesium? Oh, the oxygen had a charge of 0 and now is negative. Now, here's the thing that confuses students. When they say, well, you gained something, don't think of it that way. If you become more negative, like think of it on this number line, right? What's oxygen? It's going from 0 down to -2. Whenever you go down in what's called oxidation number of charge, you're getting reduced. If you go down, you're being reduced. How are you getting reduced? You're gaining something negative. You're gaining electrons. So the oxygen is being reduced. Now, another important fact is it's always about a reactant. It's what the reactant does. So don't confuse. If I say what's getting reduced, I'm looking at what happens as we go from left to right. The oxygen is going from 0 to -2. So it is being reduced. The magnesium, okay, is not being reduced. The magnesium is going from 0 up to +2. So it's going up. So whenever you're going up, it's going to be oxidation. Whenever you go down, it's going to be reduction. All right. So, and why is being oxidized? It's losing electrons. Now, where do the terms come from? Why do we use the term oxidation if the oxygen is getting reduced? Well, let me erase the board and pause and talk about that. See, oxidation used to mean combining with oxygen, because when you combine with oxygen, you are going to be oxidized. Metals tend to do that. Metals tend to do what we said earlier. They tend to lose electrons, and non-metals tend to gain them. So, the Statue of Liberty was not always green. Okay, the French shipped us over a statue made of bronze, copper, and tin, and the copper combines with the oxygen, okay, to make copper oxide. But it's a very similar chemical reaction, because if you think about it, the copper starts at 0 and ends up being +2. The oxygen starts at 0, ends up being -2. So the metal, once again, goes up in number and gets oxidized, while the oxygen goes down in number. Sorry, wrong place to put the arrow. Goes from 0 to -2 and gets reduced. Okay? A lot of times people worry about oxidation. I mean, iron, when it rusts, does this. It goes Fe plus O2, okay, arrow, and you make iron. You actually make a bunch of iron oxides, but one of the iron oxides you make is iron 3 oxide. And I'm not going to go back to nomenclature again, okay? But what you want to see is the Fe starts as an element 0, okay? Right? And then it turns into Fe plus 3. Right? Now, this is not balanced, I'm not buying, but notice the iron is once again going up in number. Why is it going up in number? It's losing electrons. It's losing negative stuff and becoming more positive. Okay? Well, by the same token, the oxygen is going from 0 to -2 again. Right? And we did this when we did formulas, so hopefully this is ringing bells when we did formulas, right? Note the pattern, though. When something goes up, it's getting oxidized, it's losing electrons. As it goes down, it's being reduced. And we're always talking about the reactants. We say this copper here gets oxidized or this oxygen gets reduced. We're never talking about products. And by the way, there's an Iron Age because in the Iron Age they figured out how to do the opposite of this. They figured out how to reduce iron. When you dig up iron out of the ground, you dig up iron oxide. Like you'll dig up like FeO, right? And you'll do the exact opposite. You'll do a decomposition reaction. Now watch what happens. The O is still, it's iron oxide, it's -2. The iron is +2 here, and you end up with Fe 0 plus O2. Now, when did they figure this out? The Iron Age. They figured out how to get magnetite hot enough, which is iron oxide, or so that the iron would do the opposite. It would go from +2 down to 0 and get reduced, while the oxygen would go from -2 up to 0. Okay? And so when you smelt something, what you're really doing is you're reducing the metal. And this is the stuff you build bridges with and skyscrapers with, okay? And bicycles with and cars with, all right? So clearly this was a really important thing, okay? Or, I don't know, swords, whatever. Anyway, that's it. Oxidation basically is the number goes up, reduction is the number go down. When you're oxidized, because you're losing these negative things called electrons, when you're reduced, you're gaining those things called electrons, so your number gets more negative. That is the introduction to redox. You can't have one without the other. That's why they squish them together, because this and this both happen at the same time, simultaneously, not one before the other, and you can't have one without the other. Otherwise, electrons are magically disappearing. And since we're not teaching Hogwarts, although it kind of feels that way because I'm doing this on video now, electrons don't magically disappear.